Hello everyone, very welcome to Dr. Omics. Hope you are absolutely doing fantastic. And my name is Bhushan Patil, and in this video I am going to show you that if we have a FASTA file and that file contains the multiple sequences just like this, you can say this is a FASTA file, and in that we have the multiple sequences. You can see the first one is ending here, the second one is starting from here. Okay, so for the sequences, how we can actually count the ATGC, GC content and the length of the sequence along with the ID. Not only count, but we are going to store it in an Excel file using the Biopython. So Biopython is an package of the Python language which is used for the computational molecular biology. Right guys, so here what I'm going to do is I'm going to use two packages here. One is the Biopython and second is the Pandas. So Pandas is actually used for the data analysis purpose, but here I'm going to use this Pandas library to save our data in a Excel file. Okay, so let's start. The first step is that we have to import the seq.io object from our Biopython package. For that, from bio import seq.io. This is the thing that we required for the analysis of that file. Now with the file handling, I will just open that file. Let's take a handle fasta underscore file equals to open, and here goes the file sequence dot fasta. That's it. So with this you will open your file, and this file is now ready to use. Now as we have the multiple sequences here, so what will I do? I will use my for loop to iterate over the file. For that, the syntax is for I in, I is just a variable, you can take any variable there, seq.io dot parse, and this parse function takes two arguments. One is your handle, that is FASTA file, and second is the format of the file, that is FASTA. Okay, now what is this seq.io.parse? As we have the multiple sequences in our file, we have the multiple records in our file, so this seq.io.parse is used to iterate over the file. Now if I print here the i.id, you'll get to know that you'll get the ID for all the 5 sequences here. That's it. So what will I do? I'm not going to store this in a variable. I'm going to store this in a list. For what? Because later I want to create the data frame for my data. Let's see how. You'll get to know that. I will create here a list ID which is empty. For a count, a equals to blank list. Same goes for T, G and C. Okay, so for all the parameters I have created here a list, and in that list I will add the value of ID, ATGC, GC content and the length. Okay, so let's see how we can actually add the values of the ID, ATGC, GC content and length into that list. Let's see. So list has an append method there by which we can add the values in the list with the for loop. So what will I say here? That ID dot append I dot ID. For a count, we'll say a dot append I dot seq. I.sec will return you the sequence of the FASTA sequences, only the sequence part, the ATGC. Okay, and when you will get that ATGC, you can count a particular occurrence of a letter there, the occurrence of a particular letter there, that is I.sec.count A. So this will count the occurrence of the A, and then it will append it into the list, and it will be same for the T, G and C. That's easy. Okay guys, so we have added the values of the ATGC. Let's check. Print A. Let's check A and T. Okay, so these are the values of A count for the 5 sequences, and this is for T. It will be same for the T, G and C. We'll figure out that once I will create a data frame. Okay, so what is a data frame? Data frame is a representation of your data in a tabular form. So I had to import the Pandas library here, but one more thing is left, that is the length and the GC content. So for length, it is again easy. I can count the length with the inbuilt function of the Python, that is len I.sec. I.sec holds the sequence, and len function will count the length of that sequence. Now what about the GC content? GC content can be calculated with a formula, that is count of G plus count of C divided by length multiplied by 100. But the Biopython also provide you a GC fraction function, which will help you to count the GC content, and that is very easy. For that we have to import from bio.secutils import GC fraction. This is it. After that, we had to add the values of the GC content in our list. So GC content dot append, and here goes. First I will calculate the GC content, because the GC fraction will give you the value in the decimal places. Let me show you. GC equals to GC fraction. This GC fraction will take your sequence as an argument. I.sec print GC. So you can see here the 0.4853, 0.4851, then 0.4861. So what the thing is that you had to multiply them by 100, so you will get the in the percentage. Okay, so if I multiply it by 100, that's it. Okay, so I have the GC here, and I have to calculate the GC content, GC fraction. So I will multiply this by 100. So I have stored it in a variable, and will round off it to the 2 decimal places. GC equals to round GC comma 2. This GC means this, and we have taken the same variable, so our variable will be O right there. It will overwrite the value. Print GC. So now it's round off to the 2 decimal places, and then append it. say gc content dot append gc. Now once I will create a data frame, it will look very better. Let's see. So I'm going to import here the pandas library from I will say import pandas as pd. So what is the thing here, that I'm going to refer my pandas library as pd. So let's create a data frame. For data frame, we'll create a variable df equals to and pd dot data frame. But for the data frame, I required a dictionary. Dictionary is a data structure of the Python which has the key and the values. Okay, let's see how we can create a dictionary. Data equals to, first column is the id. For id, I will create id and it will have the value as id itself. Next is the a. For a, I have the a variable in which I have stored my list. Then t. G and C, and same it will be length and the GC content as well. I will use the %GC here, and for the %GC we have the variable GC content, this one. Make sure that this ID is nothing but the variables that we have created here for the list. So this is a dictionary. If I print this dictionary, you will get to know the idea. Print data. See, this is the ID. This is A. Then this one is a T. Okay. So what will happen here basically that this will be our column headers: ID, A, T, G, C, then length and the GC. Okay. So once I will create a data frame with this, it will be visualized properly. So pd.data_frame, I will pass the data here. Data. Let's print the df, and you will see that in the tabular form. Yeah, this is what I was expecting. %GC. That's it. We have everything. Now we had to just store this in an Excel file. So to store in the Excel file, what we had to do, we had to use the pandas again, and you can see here the index. We don't want this index. Okay, so we have to remove this index, and that is also easy thing because Python is very user friendly and easy. This df will have dot to Excel method that will allow to store our file into the Excel. To Excel, give the name of your Excel file. I will use the analysis.xlsx, and I told that I don't want that index 0, 1, 2, 3, 4 in the first column. So for that I will pass here an argument index equals to false, and that's it. Our job is done. Let's run this program. Program has been run completely. Analysis.xlsx file has been created. Let's see. I will open it. Yeah. That's it. So you can see here that we have the ID, we have the count of the A, T, G and C here. That was just a small example of the Biopython. You can actually calculate the ATGC length, same thing, only if you have the IDs of the sequences as well. So that we can do with the accessing the NCBI database. Okay, so that's it for this video, and hope this is enjoyable for you. This was helpful for you. See you next time. Bye. Thanks for watching.